Hello everybody, this is Coach Tapman, and today we are going to be talking about wedges as a simple machine. So what is a wedge? A wedge converts a force applied to its blunt end into forces perpendicular to its inclined surfaces. The mechanical advantage of a wedge is given by the ratio of the length of its slope to its width. Let's look at an example. One of the more common places that we see wedges today is in a firewood axe. Obviously, using an axe to chop wood creates an advantage, a mechanical advantage that splits the wood easier than just grabbing on the two sides of the perimeter of a log and trying to rip it apart by hand, unless you're Captain America. Also on the right-hand side, we see a sword. A reason that we see swords in history is because swords actually decrease the area of impact that would be applied to somebody by swinging a weapon at them. So if you have ever taken a knife or a sword or a machete or something like that and tried to cut through, let's say, a fruit, trying to recreate Fruit Ninja, it would be much easier to cut through a watermelon or an apple or something of the sort using a sword than a baseball bat. And so really what you're doing is you're applying the same force over a smaller surface area with a sharpened edge or with a wedge than you would be with a blunt object. How do we calculate the ideal mechanical advantage? Well, it's fairly straightforward. The ideal mechanical advantage for a wedge is equal to the length of your wedge or the depth of penetration divided by the thickness of your wedge or the separation of wedge surfaces. Now these can be the same. That can be the same. You can have the full length of your wedge divided by the full thickness of your wedge, or you can just include it up to the point of separation or penetration or whatever you would call. But because it is proportional, because of the nature of triangles, the values would be the same. Now we're going to go ahead and work through an example where we talk about ideal mechanical advantage for a wedge.
Now we are going to look at an example of the mechanical advantage of a wedge. A ninja decides the best way to showcase his skills is by cutting fruit. He needs a mechanical advantage of at least 25 to get through the overwhelming shell of a watermelon, because he does not often lift weights. If he carries a sword with a length of 2 centimeters, what is the necessary width of the wedge to achieve necessary mechanical advantage? Well, we know from our equation that the ideal mechanical advantage of a wedge is equal to the length of our wedge from front to back divided by the thickness of our wedge. We are given in the problem statement a length of the wedge of 2 centimeters. We are also given 25 as our mechanical advantage. So we'll just write those in really quick. So if we know these values, we can just do some simple algebra to calculate our thickness is equal to our length divided by our ideal mechanical advantage, which in this case will be 2 centimeters divided by 25. From that, we can calculate our thickness to be 0.08 centimeters. A silly example, but a good demonstration of the equation nonetheless.